Hi everyone, I'm Anika here again for week 2 of Cup of Java and Artificial Intelligence. So today we're going to be talking about supervised machine learning, which as we talked about last time is a subset of machine learning as a whole. So let's get into it. So just kind of a review from last week's video, what is machine learning? So, machine learning is a subset of artificial intelligence, and it's a discipline concerned with designing computers that makes predictions and detect in decisions. So, there are three main types, kind of as we discussed: supervised learning, unsupervised learning, and reinforcement learning. As you can see in this diagram below, which is really helpful if you guys want to pause the video and take a look. There are varying purposes to each of these learnings. Some are used to compress data so it's easier to analyze, some are used to predict weather or do weather forecasting, and some are used to classify images. And these are all varying uses, but today we're going to focus on supervised learning. So what is supervised learning? It's a type of machine learning where the machine is trained using a labeled data set, which we'll get into later, so that it can predict the correct outputs for inputs in a labeled test data set. So labeled data just means that the input data is tagged with the correct output. So this differs from unsupervised learning because the groups are predetermined. And we'll kind of get a little bit more into all of this, and you'll understand a little bit more of this once we go over some of the vocabulary terms that come with supervised learning. So some examples is when we take comments on a social media as our input, and we can label them as appropriate or inappropriate. Or we can take an image and we can input it and label it as a cat or a dog. This kind of goes back to the image classification that I was talking about before. So when talking about data, we need to talk about vocabulary that you may encounter. If you're taking any notes, I would strongly encourage you to pause the video and look closely at this slide because it's really important. So an example is a particular instance of data that could be a picture, an image, an email, a sentence, a song, that is described only by a set of features. So here the example is X, and the features are 1.5, purple, and true. And we don't necessarily have a label to this because a labeled example is one that includes that label. So here you're going to have an X and a Y. So the X, which is the example, is in this situation, it's 1.5 green and true, and it's labeled as an apple. So for example, if we were to take the above, what we talked about above and this X and make a labeled example, it would be 1.5 purple true. And we could assume that that may be a grape because we were talking about fruits in this example, I think. So a data set is a collection of labeled and or unlabeled examples. For example, if you have this over here, the grape and the apple, and you put them together, they form a data set. A machine learning model is then a mathematical function or algorithm that outputs the predicted labels for the inputs. For example, if you have here, you have your grape, you have your apple and your grape, and the machine learning model is made to predict, okay, is that an apple or is that a grape? So training. When talking about machine learning, everyone talks about training and testing. So what exactly is training? Training is the process of using data to improve a model so that it can learn to predict the correct label of an example. And going back to our previous slide, we know what an example is. An example is an instance of data that is described only by the set of features, but it's not labeled. So the data used for training is data that is known to be correctly labeled. So this data is called a training set. And this allows the model to kind of further learn on this training data. And the model's performance during training is measured by looking at the training error, or how accurate the model's predictions are for examples in the training set. For example, if a model predicts that the model predicts that 90% of the time it's accurate in predicting between a grape or an apple, as we were kind of using in the last slide. So with generalization, what is generalization? So with training data, we are given correct labels for each example, and we can train our models to label those specific examples because they already have the label. But doing well on the training data is not only enough. You need to be able to, how do we know that our model will generalize on unseen data or data that is not the same as the training data? So here we have two vocab terms that, again, I would encourage you to write down. The first is memorization, and this is the ability to do well only on data that has already been seen before, so your training data. And generalization is the ability to do well on data that has not been seen before. So instead of memorizing the correct labels for specific examples, you can find patterns in the data that allow for generalizations. So I'm going to use kind of a cat and a dog as an example for this. So instead of memorizing, for example, memorization would be if you have a specific image of a dog in your training data set, and after, when you're not training, the model sees it again and it accurately predicts it's a dog, that's because it's already seen the image before. But generalization would be saying, okay, a cat does not have as floppy ears as a dog, but a dog does, or a cat has whiskers, but a dog does not. And a cat is smaller than a dog. And those are kind of features or generalizations that the model can use to accurately predict for all data, not just a data that it's already seen before. So there are three types of generalization in machine learning. One is overfitting, and this is when you fit too specifically to the data that you've seen before. So you're looking specifically at what you've seen rather than generalizing. Next is underfitting, where the model doesn't even learn to do well on the data that you've already seen. So the training data, the model still can predict accurately. And a good fit is that if the model understands the pattern from the training data and can generalize that to unseen data. So these are kind of plots that portray these three types of generalizations. This is overfitting. You can see it's going from point to point without really generalizing. And here, as you can see, it's not getting enough. If here you can see where it's underfitted, it's not getting enough of the trends, but here it's taking the trend into account without going into the specific of the data. So one way to avoid overfitting is to use a test set, and this is where training and testing comes into account. Then a test set is a labeled data set that we do not show into our model until after it has finished testing. So running on the model on the test set can tell us if we've overfit our model to the training set. And if this is the case, then we have to go back to our model and see what changes we can make in order to make it a good fit, make sure that the model predicts a good fit instead of overfitting or underfitting. So here are some samples. This is an example of a sample training data set. So here, the training would be, you have an input, which is a picture of the cat, and the output, which is the label of the cat. And then here you have an input, which is a picture of the dog, and the output, which is the label that it is a dog. Here, we have a sample test data set. Again, you have the picture, which is the input of a cat, and the output of a cat, that the picture is of a cat. But then the model predicts, is this a cat or not? And the prediction that it is a cat is correct. On this side, you have an input of a picture of a dog, and you have the output or the label that this is a picture of a dog, but the model predicts that this is a cat, and that prediction is incorrect. So there are two general types of tasks that we talk about when we talk about supervised machine learning. The first is classification, and this is when the label is a class or category. So the labels are discrete. So going back to our cat or dog example, if you're determining whether a picture is of a cat or of a dog, this is classification because there are only two categories. Some other examples are determining whether a book is a fiction or nonfiction, or determining if an image of a person is of a person or not. So yes or no. And again, you need not have only two categories. You can have as many as you want or as many as the model will account for. But just for the sake of simplicity during this presentation, we're going to work with two. Regression is when the label is a real number and the labels are continuous. So going back to our previous example about fruits, if you were trying to predict the size of a fruit, this would be a regression model because the label is going to be a real number. So in centimeters, how large is the fruit? So again, another thing would be predicting next Monday's temperature. This is not a yes or no question. You need to predict with numbers, or predicting the sales revenue of business 2 years from now. As you can see down here, there's some really good examples of how a model would look or a plot would look when working with classification and regression. As you can see here, these are kind of grouped into two categories, and regression is more forming a type of line. And we'll get more into graphing and plots in our next week's video, which will talk about basics of Python and how to use it when regarding machine learning. So thank you all for tuning in and watching AI video week 2. Again, as always, if you have any questions, feel free to reach out to the Cup of Java email. And stay tuned for week 3, which is basics of Python for machine learning. Thank you. Bye.